Hey folks, Mike Johnson here. If it's got wheels and an engine, you're in the right place. On this channel, we dive into car repairs, maintenance tips, and everything you need to keep your ride running smooth. If you're into cars and want to keep learning, don't forget to hit that like button and subscribe. It really helps the channel out. All right, enough talking. Let's get into it.
Your vehicle's idle control system is an important part of your car. This system prevents your engine from stalling at idle, particularly when energy-consuming accessories such as air conditioning are switched on. What happens when this system malfunctions? There are several OBDII codes that could be triggered by a faulty idle control system. One of these codes is P0506. What does P0506 mean? Diagnostic Trouble Code, DDC. P0506 means idle air control system RPM lower than expected. This means that your powertrain control module, PCM, has detected an engine idle speed below the specified number of revolutions per minute, RPM, for a specific period of time. Fault code P0506 may appear in vehicles with electronic throttle control, etc., or vehicles with a separate idle air control valve, IAC. To control idle speed, an IAC valve regulates the amount of air bypassing the throttle valve. On the other hand, vehicles with etc. have no regular throttle cable or IAC. Consequently, they rely on an electric motor to control the throttle and regulate idle speed. P0506 indicates that your powertrain control module, PCM, has detected an engine idle speed below the specified number of revolutions per minute, RPM, for a specific period of time. P0506 is a generic DDC, which means that many makes and models support it. Although it is a generic code, the diagnostic and repair steps for each case may vary depending on the specific vehicle you own. For example, the repair steps for a P0506 code in a Chevrolet may be different from the repair steps for a P0506 code in a Ford. For an in-depth look at idle control systems and how they've evolved over the years, you can read our technical discussion here. Alternatively, for a quick look at the possible causes of P0506, continue reading below. Note, the definition of code P0506 may differ depending on the vehicle manufacturer. Consult the appropriate repair manual or repair database for the exact code definition. What are the possible causes of code P0506? Here are the possible triggers for code P0506, a faulty IAC valve, a problem in the etc. system, vacuum leaks, dirty or defective throttle, body collapsed air duct or restricted air filter element, circuit problems, such as damaged wires or poor connections, a problem with the PCM. What are the common symptoms of code P0506? Your check engine light will probably come on once it has detected a fault in your idle control system. However, it can come on for many reasons, and it can be difficult to determine which part of the car is causing the problem. As a general rule, have your vehicle checked by a professional when the check engine light comes on. They'll know how to diagnose the problem further. Aside from a lit check engine light, here are some other symptoms related to the code: low engine idle speed, stalling, rough engine. Idle engine may idle erratically, in some cases. How to diagnose P0506? Diagnosing the P0506 code may seem difficult, as there are several reasons why this code could be triggered. If you're not sure what's causing this code, take your vehicle to a mechanic for a proper inspection. If you're considering fixing this code yourself, here's a video you can watch to get an idea of what the troubleshooting process might involve. How to repair code P0506. As mentioned, diagnostic and repair procedures for this code may vary depending on the year, make and model of your car. If you're not sure how these procedures work, you can consult vehicle repair manuals or take your vehicle to an auto repair shop. If you don't have the DIY skills, it's best to leave the job to trusted professionals. They'll know how to correctly diagnose the problem and rule out any other underlying issues that trigger the code. A brief history of idle control systems. Early carbureted vehicles were designed with somewhat limited idle control in the form of electromagnetic kickers, dampers that slowed the return of the throttle to the idle position, and idle load compensators that expanded with the decrease in intake manifold vacuum as the engine idled. Idle speed controls like this one were added because of power steering and air conditioning compressor load. Motorized idle speed control motors, GM's CCC and Ford's EC feedback carburetor systems, not to mention their foreign counterparts, began adding motorized idle speed control motors in the early 1980s, which typically had an internal idle following switch and a reversible DC motor turning a threaded sleeve around a threaded shaft to extend and retract a piston resting against the throttle. These motors do the same job as the old vacuum idle load compensators, but are a little more sophisticated than their older mechanical predecessors, and require algorithms in the motor controller so that when the throttle is released, the motor controller knows to control the throttle angle at idle. In addition to idle speed control, these engines also performed dashpot function, preventing the gas pedal from closing when released, which generally stalls the engine. End of the carburetor era. Towards the end of the carburetor era, some carburetor systems began to control idle speed using a stepper motor manipulated by the engine controller, allowing air to pass through the throttle plate, enabling the computer to control idle speed without actually moving the throttle plate. This became the order of the day for idle speed control as throttle body injection gained momentum, with some throttle body units still using the old engine idle speed control design. But by the late 80s, throttle bypass had become the normal way of managing idle control, even as MPI systems replaced throttle body injection. Towards the end of the carburetor era, some carburetor systems began to control idle speed using a stepper motor manipulated by the engine controller. GM and Chrysler Dodge used a stepper motor that passed current through a series of windings to slowly extend and retract a piston, to allow and restrict airflow around the throttle plate to facilitate no-touch starting, maximum airflow on engine startup, as well as standard ISC functions and the ubiquitous dashpot function to avoid stalling with a sudden release of the throttle. Ford uses a two-wire idle control that increases amperage to pull a piston against a spring. This type of idle speed control relies heavily on engine speed feedback and the angle of the throttle position sensor. As soon as the key is turned on, the closed throttle voltage is recorded and used to indicate CT for that entire cycle. The OBD2 era. As OBD2 became a thing in the mid-90s and became mandatory in 1997, some one-ton trucks still had OBD1 systems until 1996. ISC remained virtually unchanged, except that P0506 series codes, such as P0506, appeared in the ECM to PCM code list to indicate the inability of the idle control system to reach its target. Vehicles at the turn of the century began using electronic throttle bodies, which eliminated the need for idle control units, since the etc. system took over this function. ETC-equipped systems don't need a cruise control module either, for obvious reasons. In conclusion, a fault code P0506 indicates that the idle air control system is operating at a speed lower than expected, which can lead to various performance issues in your vehicle. It's essential to address this problem promptly to ensure smooth engine operation and prevent further complications. Regular maintenance and diagnostics can help identify the root cause, whether it's a faulty idle air control valve, vacuum leaks, or other related issues. By staying proactive, you can keep your vehicle running efficiently and avoid costly repairs down the line. Thank you for watching, and be sure to subscribe for more automotive insights.